The Parkinson's podcast is brought to you by the Davis-Phinney Foundation and brings you the stories, wisdom, and expertise of people living with Parkinson's, care partners, and Parkinson's professionals. In this episode, we talk with Dr. Fettah Nahab about the NEULARK study, which is exploring a new treatment designed to reduce overactivity of the LRRK2 pathway with the goal of slowing down the progression of Parkinson's symptoms. This episode is sponsored by Neuron23, who is also sponsoring the NEULARK study. Our guest, Dr. Nahab, is Vice President of Clinical and Digital Development for Neuron23.
Hello, I'm Chris Kruger, Senior Manager for Content with the Davis-Phinney Foundation. I'm happy to be here with Dr. Fettah Nahab, Executive Director of Clinical and Digital Development at Neuron23. And today we're going to discuss the NEULARK clinical trial. Before we get started, Dr. Nahab, first of all, thanks for joining me today. Can you tell me a little bit about your background in Parkinson's and how you came to work in the field?
Sure. Thanks for having me, Chris. It's good to be here. So as for me, I'm a movement disorder neurologist. I spent probably about the first 15 or 16 years of my career caring for people with movement disorders, mostly people with Parkinson's disease, and did research. I had a neuroimaging lab and worked in the university environment. And then about 6 or 7 years ago, I moved from that university and clinical care environment to start to do clinical development work in industry. And I've been in my role at Neuron23 over a little bit a year's time.
Great. Well, thanks for the background and thanks for taking some time out of your day to talk with us about this trial. So the NEULARK trial involves genetics, and maybe I think we should start there if we can. Let's start big picture with the relationship between genetics and family history of Parkinson's. I know a lot of people with Parkinson's say that they don't have the family history of Parkinson's, so there's no need for them to think about genetic factors. But that may not be the case, I think. So can you maybe talk a little bit about that and how Neuron23, who is sponsoring the NEULARK trial, is looking at genetics of Parkinson's?
I think that's exactly right. And I spend a great deal of my time actually educating people because it's frankly really confusing. And that's not just the case for people with Parkinson's or their family members. It's also confusing for clinicians and neurologists as well. What most people recognize is that there's probably no single explanation for why somebody gets Parkinson's disease. We know about the environmental factors. We know that there may be genetic factors. But in most cases, people say, well, I don't have a family history or I don't have any toxin exposures that I'm aware of. And that's generally true for most people where there's nothing we can put our finger on and say, that's why you got Parkinson's disease. Now, in terms of genetics, it's just what you said. There is no family history in most individuals. Obviously, if there is, it's a different case, and we'll talk about that a little bit more. But the assumption is that genetics doesn't play a role unless you have a family history. And fortunately or unfortunately, that's a bit of an outdated view at this point. Yes, when there are what are called mutations in genes, then that can contribute to diseases like Parkinson's. But unfortunately, that's very infrequent. In the case of the LRRK2 gene, which we're going to talk more about, maybe 2 to 4% at the top of the range of individuals have a family history and have what we call these rare mutations. Now,
Can I ask you a question there? You said 2 to 4%, that's of the entire population of people with Parkinson's has a genetic mutation?
That's of everybody with Parkinson's. Maybe 2 to 4% of them have a family history and have a rare mutation that is causing their Parkinson's disease. Yes.
Cool.
Yes. But scientists are just starting to understand that, people's DNA doesn't just cause disease. It also has the ability to make smaller impacts to where it increases or decreases their likelihood of getting Parkinson's without being a guaranteed cause. And in this case, these DNA variants, which are much more common, can still contribute to somebody getting Parkinson's disease, but can't do it by itself. And so you need some other cause to contribute in those cases. And so in the NEULARK study, which I'll tell you more about, we're really looking at individuals with both the rare DNA mutations as well as these much more common variants that are also present in people. And when you combine the two groups together, the rare variant mutations, which may have a family history, and the more common variants together apply to about 30% of everybody with Parkinson's. And so this is really a unique and something that we have to spend a lot of time educating people to, because as soon as we talk about genetics, as soon as somebody hears that, they say, well, I don't have a family history, so I don't have it.
Yeah. So I think just so I make sure I don't lose track of what's going on in this conversation, and I understand, and I'm on the same page with you, there are some genetic mutations which can be causal on their own. And that's a very low percentage of people with Parkinson's have that. But there's other variants in certain genes that contribute to the likelihood that a person may develop Parkinson's. And that's the second part of the puzzle there. Is that right?
That's exactly right. And together, because we're looking at genetic variants in something called the LRRK2 gene or the LRRK2 pathway, together we call those groups LRRK2 driven Parkinson's.
Okay, so why don't we jump into that now and start maybe go a little bit into the beginning of the conversation anyway about NEULARK at a high level. Tell me about the treatment candidate that's being investigated and what previous research has shown about it, and maybe what else you think is notable about it.
Sure, sure. So NEULARK is testing an investigational drug called NEU411. And what NEU411 is intended to do is inhibit LRRK2. Okay. And so what the goal of the study is to establish that it's safe, that it's well tolerated, and that hopefully we're able to see that it can also slow down the progression of Parkinson's disease, because there's a lot of research that suggests that when you have overactivity in the LRRK2 pathway, that increases your likelihood of getting Parkinson's.
Okay, so maybe can you talk a little bit about the connection between LRRK2 overactivity and the rare variants, and also just the sort of other variants that are known to be implicated? And yeah, maybe I'll stop there for now. Can you tell me a little more about that connection?
So we've known about the LRRK2 gene for over 20 years now. And over the years, research has determined that different of rare genetic causes are associated with different levels of LRRK2 activity. And so at a very high level, if LRRK2 activity is 5 times above normal, simplistically, people like that have about a 50% chance of developing Parkinson's disease. The more activity or overactivity in LRRK2, the higher the chance that you are to develop Parkinson's disease. And so that's when we first started to understand that there appears to be a connection between the degree of overactivity of LRRK2 and the likelihood you are of getting Parkinson's disease.
Okay, so I want to go at another little angle of this topic, which is that I think you said that well, maybe you didn't say, but the NEWARK trial is a phase 2 trial, right? So there's some previous research into NEU 411. And one goal of the current trial is to see if this treatment candidate taken for 12 months may show signal of slowing progression of Parkinson's. And that's obviously a hugely exciting possibility or interesting possibility. And yet we got to know, we want to know maybe why, right? So can you talk a little bit more about that?
Sure. So drug development is a long and very complex process with many different steps. You know, by the time a drug makes it to be able to get prescribed and used by patients, it's been through a very long vetting process. And so at the very beginning of this process, you're looking for molecules that'll have an effect on your intended target. And so in our case, our intended target is the LRRK2 pathway. And we spent years looking for molecules that could actually inhibit LRRK2. After you've identified a molecule that has that activity, then what you really want to understand is, what is its safety profile? What is its tolerability profile? What doses are appropriate to use? And those studies happen in animal models. And so you test these molecules in animal models, usually at least two species, and you look to see what doses seem to engage the target, what doses seem to be safe and well tolerated. And that data then informs where you're going to start in human trials. At that stage, you're at phase one. And phase one studies are the very first in human studies. And generally, at that stage, you're giving it to people who are healthy volunteers. They have no disease. You're giving it to them and you're evaluating its safety and tolerability profile to see whether that drug dose is going to be able to be translated into phase two. And when you get to phase two, finally, which is where we are, that's when you're testing it on the patient population of interest. And in our case, that's people with Parkinson's disease who have this LRRK2 overactivity.
And I think there's another layer to this, if I'm remembering right, that not only are you looking for people with that LRRK2 overactivity, but you're also, I think, looking for people that are not yet taking any dopaminergic medication, right? So no dopamine, no levodopa, no dopamine agonists, things of that nature. Can you talk about why that's an important component of this trial?
Sure. So that's a frustrating variable, but an important variable because everybody wants to participate in these promising early studies, but then many people aren't eligible because they've already been started on dopamine treatments in particular. And there are two main rationales for why we need people at early stages of disease and who are mostly untreated. There's a small exception to this treatment point that we can talk later about, or people can actually review on the website. But the reason to study this at an early stage is because scientists have this view that the earlier you can study a disease modifying therapy, the more opportunity there is to have a positive impact. Whereas maybe later stages of disease, the brain has undergone more damage and there's less opportunities to slow down the progression stage. That's the first important reason why we do these studies in people with early, mild, and untreated Parkinson's. The second factor is because our tools that we use to measure Parkinson's symptoms aren't very good. They're not very sensitive. And the reality is the existing Parkinson medications, all of those different varieties of dopamine medications, for example, are actually quite effective. They're good at treating the symptoms and masking the symptoms. They're not actually changing the underlying disease progression to any major extent. But because they're really good at masking those symptoms, the tools that we have to track progression can't actually see the progression happening in a short duration study like a 1 year trial. And so together, those are the two reasons why we only enroll people with those early diseases and who are generally untreated.
Okay, yeah, thanks. I can see how that would make it a little more complicated to evaluate what's going on in a trial if you're seeing people that are taking a variety of different medications potentially, or really any medication. So yeah, thanks for giving me a little more information about that and the audience as well. So I think you've talked about one innovation so far, and I think there's others that maybe we can talk about in this conversation. And that innovation you've already talked about is the idea of LRRK2 driven. That's a term that Neuron 23, as I understand it, has sort of, that's a concept that's come out of Neuron 23. Is that right?
I think LRRK2 driven may have been in the literature before, but it's our definition of it, which includes both these individuals with these rare variant mutations, as well as this much more common group of variants that apply to about 30% of the overall population that we combine together to call LRRK2 driven Parkinson's. Yes.
So in that context, there's another layer of innovation in this study, which is the screening process to determine who's eligible for the trial. Can you talk a little bit about that, please?
That's right. So, DNA testing, genetic testing in Parkinson's isn't such a common thing. It's becoming more common, which is fantastic with studies like PD generation, where many more clinical sites, many more patients will provide samples to have their DNA shared with researchers to try to better understand the causes and the progression of Parkinson's. Now, those sort of tests, or even a clinical test that a neurologist may order on their patient who has a family history, doesn't identify everybody with LARC-driven Parkinson's. And so there's been no opportunity to identify that larger group. And so we've worked with partners to develop what's called a companion diagnostic, where you're able to provide a sample. Initially, to be eligible for the study, you would provide a saliva sample, and we would run your DNA profile and determine whether you were LRRK2 driven or not. And if you are LRRK2 driven, then you would be eligible to be evaluated for participation in the NEULARK study. So that's a little bit of an innovation, because in most trials in Parkinson's and frankly neurology in general, it's an all-comers trial. Anybody with a diagnosis is eligible to participate. And one of the things that we're trying to innovate is moving neurology and Parkinson's care to more of a precision-based approach, something that you see much more in oncology, where only people with a certain genetic profile are eligible for particular therapies. And so from our point of view, we're only going to be testing the right individuals to be tested with a targeted therapy to see if that targeted therapy can actually slow their disease progression.
And can you clarify for me how this works in this trial? If I signed up today and I said, "Hey, I want to try see if I'm eligible for this," what would happen? Can you tell me about that?
So there's a few different ways to enter the study. For most individuals, if they go to the NEULARK website, they can learn a lot more about the study, the details, what we're testing, that sort of thing. And then there's a link to be able to go and get tested for this LRRK2 driven Parkinson's. There's a very brief questionnaire which asks you questions like, have you been diagnosed with Parkinson's? Are you currently on any treatments? And it asks you about your age, because we're only testing individuals within a particular age range. And based on your responses, you're eligible to receive a saliva kit by mail, or you could even get it at a particular research site if they're participating in the NEULARK study. And then you provide the sample, and within a few weeks, you'll get the results back telling you whether you're eligible or ineligible to participate or to be screened in the NEULARK study. Those who are eligible would then be referred to a clinical trial site where they'll go into much more detail about the study. They'll need to review the consent form, sign the consent form, and then go through a screening phase before they're eligible to get the drug.
Well, I'll just add a personal experience here. I happen to live with Parkinson's, and I've participated in some clinical trials, and I've gone to sites and had a whole day almost at a place, and then they tell me at the end I'm not eligible, and it's a little frustrating. So I appreciate, as a person with Parkinson's, the idea that I could get something sent to my home as the first part of this process to make sure I don't have to spend time doing something that I may not even be eligible for. It seems like it's an efficient way for me to see if I'm eligible anyway.
That's exactly what we intended. I think the reality is, if only 30% or so of individuals are eligible, we don't want to waste people's times. We want to give them an opportunity to do this to where they don't have to drive to a clinical site, spend hours and hours getting assessed, only to get that bad news at the end, which is, I'm sorry, you're not eligible. And so for our purposes, at the very least, we want to clarify that LRRK2 driven eligibility before we do anything else.
Yeah, well, thanks for paying attention to that. Let's move on to the next question, because I don't think we haven't covered all the innovations in this trial yet, and there's maybe another one that's worth talking about in regard to how the results of the trial will be evaluated. Can you talk about that?
Sure. So one of the biggest challenges in testing medications in clinical trials of Parkinson's is the amount of variability. When I was caring for people with Parkinson's, one day I would see them and they would be feeling good. And another day I would see them, they don't feel so good, but that may not necessarily be an indication of the fact that their disease was progressing. And so, in the setting of a clinical trial, most clinical trials will see people on a monthly basis. And if I see you at your baseline visit and then you come back at the 1 month follow up, and the night before you didn't sleep so well, or there was some sort of a family issue that was going on, you might look worse, but it has nothing to do with your underlying disease progression. And conversely, you got some really good news before your study visit and you go in and you're glowing. That may not be an indication of the fact that the drug is actually working. And so, because of this great deal of variability that is present, relying on these in person clinic visits to gauge whether a drug is working or not working, or side effects are related or not related, we are giving all of the participants a smartphone to take home with them, which has an app. And that app will require you to do about 5 to 10 minutes of assessments on a daily basis. And when you do those assessments, some of them are movement related, some of them are due to thinking speed, that sort of thing. And so when we track your progression on a day to day basis, it's a much easier way of trying to gauge somebody looks like they're actually doing well over the course of the entire year of study, rather than relying on month one versus right at the beginning, or 12 months versus right at the beginning, because of that variability issue. And so this is trying to use technology to advance the ability to be able to track disease progression. And I'll tell you, there's another advantage here. You mentioned that study visits can be long, they can be annoying, they require you to drive to the site. It may take 3 to 4 hours at the site. And so when you're doing these 5 to 10 minute assessments on a near daily basis or a daily basis, that's less time that you have to spend in those in clinic assessments. They're still there. We still, use that data, but it's much more of a lesser burden on individuals when you're breaking it up into tinier pieces.
Yeah, I want to just add that the flip side can be true too, where the visits can be really lovely for people with Parkinson's to go to, because you're in a community of people that are paying attention to Parkinson's all day long. You can learn some new things. So I've had that experience too,
That's
and
a
that's beneficial.
that's a really good point, because I think when I saw people historically that were participating in trials, most people don't have a lot of clinical trial experience, and they have some reservations because, this is a big commitment. It takes a lot of time. And I think it's important for many people to understand that participation not only benefits the scientific community and, future generations of individuals, but most individuals who have participated have told me how personally fulfilling and satisfying it was to learn more about their disease, to be able to interact with the study staff. And so I completely agree with you.
So what else is noteworthy to you about the trial? Is there anything else we haven't covered about the trial in particular?
So, not necessarily innovative, because these sort of trials do occur elsewhere as well. But in most trials, there is a drug and there's also a placebo, because we need to understand what the differences in progression rates are. And obviously, nobody wants to get the placebo arm. But at the end of the 1 year trial in NEULARK, individuals that are interested will be able to participate in what's called an open label extension. And that open label extension means that whether you were on drug or on placebo, you're going to get drug. And so that open label extension allows us to be able to monitor the safety data for a longer duration of time, while providing everybody who participates with access to drug for an additional period of time.
Yeah, that's important. It was an important component for me when I was thinking about what trials I would participate in the past. If I'm going to give, it'd be nice to get some part of the experience, if there's reason to think it might be helpful. So yeah, that's interesting. Thanks for sharing that. Now we'll put some links to the relevant information that where people can find resources about the trial online in the description. I wonder if maybe you can just talk a little bit about, how if somebody's interested in learning more about this, who should they talk to? What should they do if they want to learn more?
So I think I already mentioned this, but this is a big commitment. Any participation in a clinical trial requires a lot of effort, time, resources. And so it's important for people to be as informed and educated about the process, ask as many questions as possible. The best place to begin is at the NEULARK website. It describes information about the study. It talks about NEU 411. It talks about LRRK2 driven Parkinson's disease, and it gives you that link to the site to be able to get that genetic testing done to see whether you have LRRK2 driven Parkinson's. I will say that that small subset of individuals with the rare variants, for those individuals, if you know you already have this, you can skip that first step and go straight to a clinical site that is participating in the NEULARK study and be able to learn more information by communicating with the site. The sites are the best places to ask the questions about the study, the commitments. And once you get that information, you can review the consent form on your own time, ask questions, come back, discuss it with your loved ones, with your care providers, whether it's your neurologist or anyone else, and come to agreement about whether this is something that you're interested in and willing to participate and help to advance science. And the other thing to mention is because there are constraints on needing to drive, those sort of things, we do as much as we can to try to minimize those burdens. And so if you're somebody that doesn't have anybody to take you to a clinical trial site, please talk to your clinical site because there are ways to get transportation. If you're somebody that is far from a site, there are still ways to be able to do this. And so nothing is really off the table, but it's a discussion to have and to decide whether this is the right decision for you. The other part of this, as I mentioned at the beginning, that we're looking for individuals that are not on dopamine treatments. Well, ideally, those individuals would not begin dopamine treatments before the end of the study, but on a case-by-case basis, some people may not be able to last that entire year's time of the study and may need it sooner, and that's still possible to occur. But obviously, once you go on the dopamine treatment, we lose some of that ability to be able to track your disease progression. It doesn't nullify the data, but it's something just to be aware of.
I guess I want to ask maybe one more question. Just, is there anything else you think that people with Parkinson's might think about before they start participating in a clinical trial, or as they consider if they want to participate in a clinical trial? Anything we haven't talked about?
Well, when I saw patients on a daily basis in my clinical practice, every time people would come back, they'd ask, so what's the latest and greatest? What new medications are coming down the pipeline, and what's possible for me to get soon? And we talk about the fact that, the probably the greatest rate limiting step in clinical trials, we already know they're complicated, but the biggest rate limiter is really enrollment. If we could enroll the entire study on day one, we would be done in a little over a year. But because, you have to find the right individuals with the right eligibility who have the ability to commit that time and effort, blood, sweat, and tears, that takes time.
I think you meant blood, saliva, and tears.
That saliva too. Yeah, we have to modernize that saying. Exactly. So, from my perspective, science cannot advance. We cannot get new treatments without people giving of themselves, whether it's time, whether it's effort. The trials cover all of the related costs from that point of view, but there's still a huge time and effort commitment, not only by the individuals, but their loved ones as well. And that's really the thing that helps scientists to learn new things, to make advancements, and hopefully to bring new treatments to market eventually once we're able to demonstrate that a new treatment is safe, tolerable, and effective.
Yeah, so I think I would summarize what you just said as follows, and tell me if you think this is fair. While people ought to pay attention to their own needs in terms of their own treatment, without people being willing to participate in clinical trials, the process of developing new treatments is going to be a lot slower than if people the more people you have, basically the faster the progress can be made in sort of advancing understanding and potentially new treatments, and eventually maybe even cure or cures for Parkinson's. Is that a fair way to summarize what you've just said?
Very well said.
Well, thank you for your time and for your work on this trial, and I'll look forward to hearing more about it as progress is made, and maybe we can have you back again as the results come out and we can learn more about the results of the trial down the line. I said already that we'll put links in the description, so do look in the description so you can find links to the trial website and more information on our website about clinical trial participation as well. Thanks again, Dr. Nahab, and I'll look forward to talking with you again soon.
Thank you for having me.
Thank you for joining us for this episode of the Parkinson's Podcast. For more information about the Davis-Phinney Foundation and to learn about educational offerings and community events for people affected by Parkinson's, please visit davisfinneyfoundation.org or dpf.org. This content includes information, insights, and opinions from our Parkinson's community. The views expressed are those of individual participants and do not constitute medical advice. This content is not intended to substitute for the guidance, advice, or recommendations of your personal healthcare providers.